let's start working on exam 2 review over chapters 14, 15, and 16. The first question is asking when the gases carbon monoxide and hydrogen gas are combined in a sealed vessel and heated, they will eventually form an equilibrium mixture of reactants and products according to this balanced equation. In one such reaction, 3 moles of one reactant were combined with 1 mole of the other reactant. So 3 moles of H2 plus 1 mole of carbon monoxide in a fixed volume. Analysis of the reaction mixture at various times gave the results below that you see in this graph. Which component of the reaction mixture is represented by curve B? So the key is in the initial number of moles of the components, the reactants that is already mentioned in the question. Which one you have 3 moles 3 times as the other one, H2, right? So if you consider it like 3 moles, this would be 1 mole. So, and this is going to be 0. Sorry, here. So H2 is curve A and curve B is going to be carbon monoxide, and C is one of your products, whatever it is. So it goes from 0 to the equilibrium concentration. So that's how you choose carbon monoxide. That was question number 1. Question number 2, we still have some space, so let's work on it. You have this equation, 2HI given H2 plus I2. You initially have 5.80 atmosphere of HI. So at the beginning you don't have anything, right? No pressure for the products. And during the change you have minus 2x, correct? Because of the coefficient. And then you have x will be added to H2 and I2. So at the end you have 5.80 minus 2x, and at the end for H2 and I2 you have x amount. The question is saying that it is found that the partial pressure of H2 is 0.56 atmosphere at equilibrium, 0.56. So your x is 0.56. Write it here so it won't be confused. So x is 0.56, and then concentration or partial pressure of HI, we're supposed to find the partial pressure of HI at equilibrium is 5.80 minus 2x, which is 2 times 0.56, which is going to be 4.68. That's how you choose C. For 3, question number 3, these are all equilibrium questions, so needs a similar procedure. Question number 3 gives you another equilibrium equation, 2NO N2O plus N2H4 is going to give 3N2 plus 2 water molecules. Initially there are 0.100 moles of N2O and 0.25 moles of N2H4 in a 10-liter container. If there are 0.059 moles of N2O at equilibrium, 0.059 moles of N2O at equilibrium, how many moles of N2 are present at equilibrium? So let's see what is the situation of the system. At the beginning, nothing, and during the change you have minus 2x minus x plus 3x and plus 2x. So during the equilibrium, system has reached to 0.100 minus 2x, 0.25 minus x for into H4, for N2 is 3x, and for H2O is 2x. So the question is saying that this 0.100 minus 2x is equal to 0.059 because that's the equilibrium number of moles for N2O. So x from this equation is going to be 0.0205. And since the number of moles of N2 is 3x, so it would be 3 times 0.0205, which you will find as 0.0615. And since the answers are given in scientific notation, it would be 6.2 times 10 to negative 2 moles. So you see, you are dealing with the moles, not the concentration, so you don't need to divide by the volume of the container. So that's how you pick C, which gives you the correct answer. Question number 4. Question number 4 is asking for the expression for Kc, CaSO3 in solid form, CaO in solid form, plus SO2 gas. So let's write the Kc. What do we write for Kc? Only gaseous compounds. We do not include solids or liquids. And Kc is written by dividing the concentration of products over the reactants. The only product in gaseous phase is SO2. There is no other product or reactant in gaseous phase, so it's simply SO2, which is B. That's how you choose B. For question number 5. What is the balanced equation? That's the opposite of question number 4. Kp is given. You know that instead of Kc, you can write Kp whenever all the components are gases. So PSO3 squared divided by PO2 times PSO2 squared. So we know that the top is the products and the bottom is the reactants, and they are to the power of their coefficient. So let's build the equilibrium first. What are the reactants? O2. What is the coefficient? 1, because there is no exponent, plus SO2. What is the coefficient? 2, because that's the power. And on the other side we have SO3, and the coefficient is 2 because that's the power. That's how you build it, and the answer is going to be A for this question. Question number 6. Question number 6 is asking for the amount of Kc for this reaction. Br2 plus Cl2 gives 2BrCl. They're all in a gaseous form, gaseous state, which is important in writing Kc. So Kc is BrCl squared divided by Br2 times Cl2, right? So we are supposed to find Kc. We are given the molar concentrations. So for BrCl we have 1.24 times 10 to negative 3 squared divided by 0.484 times 0.105. So Kc is going to be 3.02 times 10 to negative 5. So it would be A. Should give you A. Question number 7. Again, you need to find a constant, an equilibrium constant. You have 2HI in equilibrium with H2 plus I2, all in gaseous phase. We're supposed to find the Kp, but the partial pressures are not given, the number of moles are given, and we are supposed to find the molarities first and then find the Kp. So Kc, we have the number of moles in equilibrium, so let's just divide all of them by the liter, so they change to the molar concentrations, because you cannot put moles, you need to put the molar concentrations. That's the products divided by, and you are lucky here, but there is a problem with the answer key. A and C are both 0, so whichever you calculate is enough. So means that there is nothing left from HI, so there would be no Kc and no Kp. Or you can just say that Kp and Kc are going to be the same because delta N is 0. But because there is nothing left from your reactant, so there would be no equilibrium constant for, and there is no equilibrium concentration for Kc, so 0 moles, so there is no Kp also. So 0 either way, A or C, whichever is 0, you choose that. In the answer key you have A. So for A, for 8, that was question number 7. Question number 8, for which of the following equilibria Kc is equal to Kp? Instead of just going through all of them, just investigate the condition that Kc is equal to Kp. Kp is Kc RT delta N, right? When do you have Kp equals to Kc? When this is going to be 1, right? When it is 1, when delta N is 0. So find the equation where the delta N is 0. For 8, part B, you see CO plus H2O gives CO2 plus H2. You have 2 moles and 2 moles, so delta N is going to be 0. Any number to the power of 0 is going to 1, so Kp will be equal to Kc. These should be very quick questions that you answer quickly. You shouldn't waste that much time on them. Question number 9 is giving you 2 CCl4 in plus O2 gives you 2 COCl2. This equation is given, and Kc for this equation is given as 9.9 times 10 to 51 times 10 to 51. And we are supposed to find the equilibrium constant for for this. Let me number them as KC1 and KC2. So you had it in PowerPoint slides when the equation is multiplied by the number, so the K equilibrium will be to the power. So you can say KC1 because the relation between these two is that the coefficients in equation 1 have been divided by 2 to give the coefficients of equation 2. But also, so let me call it equation 1. Okay? But also, if you multiply equation 1 divided by 2 and then reverse it, then you will get equation 2, right? Equation 1 divided by 2 reverse. So you can say that KC2 is 1 over KC1 and to the second root. You can easily write down the reactant to the product to the reactant and examine it. So you just need to reverse that 9.9 times 10 to the 51 and get a square root. It would give you 1 times 10 to 26. So basically, again, the relation between equation 1 and 2 is that equation 2 is half of equation 1 plus its reverse, because you see 2 COCl2 on the product side, but you see just 1 COCl2 on the reactant side. So it's not only flipped, but it's divided by 2. So you divided by 2 means you get the square root because the coefficients appear as the exponents. And then you inverse it because the reaction is inversed. Question number 10 is conceptual. Let's read over it. Which of the following is true for a system whose equilibrium constant is much smaller than 1? When equilibrium constant Kc is smaller than 1. Kc is products over the reactants, right? So when the equilibrium is smaller than 1, the reaction mixture contains mostly reactants at equilibrium. B says contains mostly products at equilibrium. The rate of reaction is very slow, and the moles of reactants and products are relatively similar at equilibrium, both A and C. We cannot say the reaction rate is slow because equilibrium is the rate of forward and reverse, which are equal to each other. So the only way that we say whenever the Kc is less means that the ratio of products to reactants is very low, means that the reaction is mostly at a reactant state. So you have only mostly the reactants. A. For 11, you are working with Q, right? You are given 2HF and then H2 plus F2, correct? Then given that 1 mole of HF, 0.2 moles of H2 and 0.75 moles of F2 are mixed, we are not talking about the equilibrium conditions. Kc is given. Kc is given as 1 times 10 to negative 2, and equilibrium and non-equilibrium moles are given. So, and we have a 5-liter flask. So determine the reaction quotient. We learned that reaction quotient equation is written just exact same as Kc, but the values are not equilibrium values. They can be at any time in the reaction. So we have hydrogen times fluorine times HF squared. And since we need to plug in the molar concentrations and in the equation, you are given the moles, go ahead and divide the moles by the volume. So you have 0.200.5 for H2, right? Yes. And you have 0.750 divided by 5 for F2. For HF, you have 1 divided by 5 squared. Then it gives you Q, which is going to be 0.15. So you will choose B. Question B, question 12. In question 12, you are given 4NH3 plus 3O2 gives 2N2 plus 6H2O, correct? Yeah, suppose that 0.3 moles of NH3 and and 0.4 moles of O2 are added to a 5-liter container if X moles of water is present at equilibrium. So this is initial condition, which is 0 and 0. And at equilibrium, you have X moles of water present. We are going to find the equilibrium concentration of oxygen. So, in order to make it easier, my suggestion is that let's try to simplify it. Let's just have the concentration of H2O as X. So the coefficient is 6. Let's divide every coefficient by 6. Okay? Now, write the new excuse me. Write the new coefficients in a new equation. 4/6 is 2/3. We're simplifying only. Plus 1/2 oxygens. Here you have 1/3 and you have H2O. So H2O at equilibrium is 6, right? So let's determine the change. You have minus 2/3 of NH3, correct? We're just focusing on new equilibrium. And we have minus 2/3 X. Minus 1/2 of X. And here we have plus 1/3 of X and plus X. We divided by the value of the given, the one which is given X, to make it easier. Instead of dealing with 6X and the stuff, let's just have it as 1. So the equilibrium for NH3 is going to be 0.3 minus 2/3X. For oxygen is 0.4 minus 1/2X. So what do we have? 0.4. Okay. And then this is the number of moles, right? This is moles. We need the concentration, so we divide it by what's the volume? 5.4 minus 5 divided by 5, which gives you 0.0 8, you just divide this. 0.4 divided by 5 minus 1 over 5. So you will have 0.08 minus 0.1 x, which gives you C as the correct answer. That was a little bit different, but the trick is that if the reactant or product whose equilibrium concentration is given as x, it has a coefficient, divide all of them by the coefficient, and then it takes you to the rest of the solution that you already know. And at the end, if you're looking for the concentration, divide it by the volume of the flask. All right. Next question is question 13. The following equilibrium is exothermic. 5CO2, both of them are gas. They are in equilibrium with their products. 5CO gas plus, what else do we have? I2O5 gas. So the following equilibrium is exothermic, means it releases heat. Delta H is negative. How could the yield of iodine pentoxide be increased? Which one is iodine pentoxide? This means how can we increase the amount of iodine pentoxide? If delta H is negative, it's releasing heat, means it doesn't need heat. So decrease the temperature to have more product. Okay, so 3 is D. Because it's exothermic, we just need to decrease the temperature because it doesn't need heat. If it was an endothermic, then you should have increased the heat. Question number 14. Which of the following reactions is not readily explained by Arrhenius' concept of acids and bases? So for Arrhenius acids and bases, acids release hydrogen ion in aqueous solutions, and bases, they release OH, hydroxide, in aqueous solutions. So in which of them you don't see such a thing? For A is following the Lewis theory. So A is not the one that follows the Arrhenius theory. We don't see the release of any hydrogen or OH in the solution. Question number 15. Which of the following statements is correct concerning the neutralization of sulfuric acid by a strong base? Question number 15. We still have some room here. 2OH plus H2SO3 gives, there is an arrow missing here. Sorry, my bad, it's not my fault. Okay, so the question says which one is correct. A says H2SO3 is both an Arrhenius acid and a Brunstiller acid. We have the Arrhenius concept for acid. Has it released hydrogen ion? Yeah, we don't see the hydrogen ion on the other side anymore. And according to Brunstiller theory, it's a hydrogen ion donor. So A is the correct answer. If you examine the rest of them, B is just opposite of A. C says is neither of them, which is not correct. And again, D is contradicting A. And E is just talking about the Lewis basis, not the Lewis base. For question number 16, What is the conjugate base of H2PO4 with a negative charge? H2PO4 with a negative charge. Conjugate base. So if it's a conjugate base, you were looking for the conjugate base, so H2PO3 is the acid itself. So between the base and acid, which one has one more hydrogen ion? One more hydrogen ion. So base has one less hydrogen ion. So take one hydrogen ion from here. And because it was a positive charge, you deducted one more positive charge, and you have to increase the negative charge here. So you choose HPO4 with a negative 2 charge. Question number 17. Which of the following species cannot act as a Lewis base? What is the definition for Lewis base? You need to know the definitions for these three theories really well by heart. It's not given. Lewis base is the electron pair donor. You remember in Lewis theory, acid is acceptor. So electron pair donor. So the species should have enough electrons to donate. Which one of them does not have electrons to donate? The one which has a positive charge, aluminum, which is C. And before we finish this part, let's work on a few more questions. So question number 18. The acid strength decreases in this series given. Question 18. HBr, HSO4, CH3, COOH, HCN, double up more space, and HCO3 with a negative charge. So this is the strongest, right? And this is the weakest. The question is, which of the following is the strongest base? So the weakest acid will have the strongest base, right? You remember the conjugate acid-base pair, if one of them is weak, another one is strong. So it has the strongest base. How do you determine the strongest base? Acid has one more hydrogen. So the strongest base, you deduct one hydrogen and increase the negative charge, which is B. For number 19, which of the following statements is true concerning an aqueous solution of the weak base NH3? It says it's a weak base. So A says OH is a stronger base than NH3. Of course, when we say it's a weak base, and we know that OH is the strongest than any other bases. So A is the correct answer. And to finish this video, let's work on this question number 20. Which solution has the highest pH? Highest pH means weakest acid, because the strong acids have low pH. Weakest acid. So let's determine the weakest acid. We are determining the weakest acid amongst HBr. The molarities of all of them are the same. HBr, HI, HF, HCl, and HClO4. We are looking for the weakest acid. This is the strongest, so this is not the choice. And we are comparing between HBr, HI, HF, and HCl. Down a group, the acidic strength increases. So the one on top is the lowest, has the highest pH, means it's the weakest. So for 20, C is the correct answer. Okay, in the next video, we will continue with the rest of these questions.